The Utility Service Center was built in 1966, and originally it consisted of just 2 buildings. There were 7 major additions over the years, and each of those pretty much had their own HVAC system, sometimes different types, all over the building.
And because we've had so many different systems put into this building, our current building here at 700 Wood Street is one of the worst in energy efficiency.
So what we have here is an example of one of the many existing mechanical rooms. Some air handling units, roughly 25 years old, past the end of their service life. They've got the old pneumatic airline controls, extremely energy inefficient. We're going to be demolishing all of this equipment, and the new equipment will be all digitally controlled.
A major portion of our greenhouse gas emissions is energy use in our buildings. So this building really ended up being a good candidate to see how we might be able to lead by example in the city.
This project started out looking at how do we remodel this building to bring this building up to a state-of-the-art building.
There's been remarkable advances in efficiency in all types of systems. The winner that came out on top in terms of energy and maintenance savings and everything else was the Geoexchange system. For the heat exchange reservoir, we had the option of drilling boreholes in the ground, which is more traditional. We would have had to pull up pavement and parking lots and drill a bunch of holes and make a big mess.
And Mother Nature's been very fortunate to us to give us such a large body of water right adjacent to this utility building. And we were able to avoid drilling of any kind by putting our heat exchangers on the bottom of the lake. Of course, this could not have happened without our partners, Jeff and Zia, and their willingness to be community-minded and work with us.
When the city approached us about using the lake, we thought that would be a pretty interesting idea because we have our own geothermal system that's operating in the garage. Relatively simple system.
We did have some concerns though, mostly environmental.
Right, we didn't want to negatively impact the wildlife, the fish, and the aquaculture that was there.
So we contacted the state Parks and Wildlife. He actually came up and visited with us, walked around the lake, and basically assured us and them that there was not going to be any negative impact to the fish.
Before putting this new system in, we wanted to reduce the cooling and heating loads in the building. So the first step was upgrading the building envelope. In all the areas, the drywall is being pulled off, the walls are being insulated with a high-performance foam insulation. High-performance windows are going in the building. So putting the heat exchangers in the lake was a remarkable day for us.
That we've come to this point of completion after 4 years of working together.
The location's been determined as to be the deepest part in the lake. There's some flotation bags on the heat exchangers. They're going to be picked up with a crane and lowered into the lake. There'll be some divers out there to help position them. The air will be let out of the float bags and they'll be lowered into place.
For future growth, we actually installed 4 plates because we have other buildings that we'd like to include in the coming years.
Our Geoexchange system consists of a continuous loop of pipe that runs throughout the ceiling of the building, out to the heat exchangers on the bottom of the lake, and back again. Heat pumps in various rooms of the building are connected to the loop, and a pump continuously circulates a fluid through the whole system. Heating or cooling of the building is accomplished by using this fluid to transfer heat. In the winter, when the building needs to be heated, the heat pumps in the building use a cold refrigerant to draw heat out of the liquid in the loop. The refrigerant is pressurized, becomes hot, and then transfers its heat to fresh, filtered air, which is used to heat the building. Since heat has been taken from the liquid in the loop, the liquid becomes cooler. So it circulates out to the heat exchangers in the lake, where it's warmed by the lake water. A valve drops the pressure of the refrigerant in the heat pump. It becomes very cold again and is now able to absorb more heat from the loop. In the summer, when the building needs to be cooled, the system is reversed. The heat pumps now use a cold refrigerant to draw heat out of the air in the building and transfer it to the liquid in the loop. The building becomes cooler and the liquid in the loop becomes warmer. So the liquid circulates out to the heat exchangers, where this time it is cooled by the lake water. It can then return to absorb more heat from the air in the building. The lake water itself only warms or cools the heat exchangers at the bottom of the lake and is never used directly in the system. For much of the work on this project, we were able to reduce costs by utilizing our own light and power crews. They used directional boring to create a 200-foot underground borehole to run the pipes that connect the heat exchangers in the lake to a new mechanical room that was constructed in the building. It's a very simple system, very few moving parts. There's high-density polyethylene pipe in the ground that doesn't deteriorate, stainless steel heat exchangers in the lake. Heat pumps within the building are very serviceable. So this system could be around easily for 50 years.
When I bring employees back into their offices, they get to come into a clean environment that has new windows, has new HVAC system. This is their home away from home. This is something that will benefit us, it'll benefit our community.
And it proves that we can heat and cool a building with this sustainable technology.